This little fella you see on the screen right now is my latest project. And no, I'm not talking about Majima, I'm talking about the LED matrix that you see, currently displaying some of the digits of pi. My LED matrix is just really a couple generic panels, exactly the same kind of stuff that you will see out on the street. And they're being driven by a Raspberry Pi 4. Let me share a few details about how I went about this. Hi everyone, and welcome back to the channel. This project, it's always been a dream project of mine. I had a Pixu 64, but it is currently e-waste. It is just e-waste right now. Take a look here. First of all, you have to buy your matrices. You can just buy them from anywhere, but Adafruit sells this stuff. And I'm gonna share a link to this in the description because, well, this is a very, very simple tutorial. This stuff is for kids actually, so it is that simple. Okay, so the Raspberry Pi has a component called the hat. This is a little PCB that sits on top of the Raspberry Pi and interfaces with the GPIO. This comes pre-wired and pre-designed, so it works to successfully drive LED matrices. You just have to do a little bit of soldering to get the connectors in place here, but once you have everything soldered, you just place it on top of the Raspberry Pi, you're off to the races. Of course, you could manually wire everything, you know, cable by cable if you wanted to the LED matrix, but I'm lazy. So, okay, so you have your ribbon cable and everything connected and to power and everything else. And then you have to download an installer script from Adafruit. This is in this repo. Basically, some people may be using the hat version. There's a smaller version called the bonnet, intended for Raspberry Pis such as the Zero W, and some other people just wire it directly, as I mentioned. Depending on what solution you're using to drive your matrices, you download this script and it's gonna ask you, you know, to configure it depending on what you're using. Once you configure all of that, it's gonna install drivers and utilities to your Raspberry Pi, and basically you pipe text to it. This is how it looks. As root, because since this interfaces with the GPIO, you need root. Of course, there's a way to modify things so you don't actually need to escalate permissions to interface with the GPIO, but you know, I just decided to run everything as root. So okay, so here in the root home directory I have a script called run.sh. Run.sh looks like this. So it is a shell script pointing to the text scroller utility that the Adafruit installer generates for you. You also have to compile some C code, but it's really simple stuff. You literally just punch make and it does everything for you. So, and the font, so I generated that with a BDF font generator because you cannot use true typefaces for this. You need a bitmap font, but it's very easy to generate. Just look up a BDF font generator and just follow the instructions. And for extra kicks, I decided to use the classic arcade typography, right? Because I love video game typography. Text scroller expects a color parameter. I generate a random color, just, you know, generating 3 random numbers. Let chain is to point at what the dimensions or what the resolution you actually have on your, you know, on your panels. So in this case, it works for me with 4, even though I have 2. LED hardware pulse and the kind of mapping that I'm using the hat mapping. An offset of -3 works for me vertically because of the way that the font is rendered. So if I didn't use the -3 here, then the text will be too slanted. S is the speed that you scroll with, and L is the length of the animation, so I point both to S5 and L5. Okay, so what this script does is that it just throws a die. Depending on that, it picks a random command. So the idea is to expand this over time with new texts, right? I use it as a clock, so I just print the output of the date command and the uptime command. And the idea is to sort of expand this over time with random tidbits. So since you are in Bash right now, so effectively you could just pull something from an API or from an RSS feed or whatever and just display it. How lovely is that? And then just picks a random command and runs it. And then the script dies. So Vim, this is how my service looks. So I use systemd to run it. So it's a service configuration file. I use restart always, user root, because again, I need permissions to access the GPIO, and exec start, right? And I point it to the script. So that way, the script, the systemd will continuously run the script. Then once it dies, it will restart it again. And this also has the advantage that it's unattended. So if I turn off the computer and turn it on again, it will run on its own. It will start displaying text on its own. So once you have all of this in place, it's as simple as systemctl enable lets. This enables the service in systemd, right? See, and there we go. It just restarted. Really simple stuff. Again, just follow the tutorial here. Use a similar approach to what I have. Once I make updates to this, because I'm thinking that I'm probably gonna add a Bitcoin ticker or a GameStop ticker. So I don't know, we'll see. Once I have updates, I'll post another video. For the time being, however, thanks for hanging out, and I'll see you soon.